We got a problem. Cities are growing and they're growing too fast. 60 million people are moving to cities and urban areas each year. That's more than 1 million every week. There will soon be 59 cities with populations over 5 million. And cities emit more than 80% of the world's carbon dioxide. And that's a problem. But we got a solution. We're going to tell you what it is, and then we'll watch a crazy scientist blow up a trash can. So we got a problem, and when I got a problem, I find a smart guy. Enter John Cohn, IBM fellow, mad scientist, superhero. John, what is it that you folks are doing here at Burlington that's helped making this site work better?
Well, this facility makes amazing stuff. We make chips for video games and cell phones and GPS. It's a very energy intensive process. But it turns out that a lot of our energy goes into cooling water and air to cool all the equipment.
Okay.
We have a supercomputer down in Yorktown called Deep Thunder.
That was with Bruce Willis and Sidney Poitier?
Oh, I love that movie, yeah.
That was great.
No, this thing is amazing. It can make a weather prediction, not just like for the area, tomorrow it's going to be sunny. It'll tell you within a 6-block region what the temperature is going to be every hour, and more importantly, what the humidity is going to be. Okay. So if we know it's going to get a little bit cooler, we can actually use the cooler and drier air to help cool the water.
It's like opening a window.
Yeah, like a big, fancy, expensive window, exactly.
Okay.
By using that information, we've been able to save hundreds of thousands of dollars a year in our electric bill and put a whole lot less carbon up in the air.
That's pretty good savings.
Yeah, it's not bad. And I think if it worked here, it would work in a city. It might even work in your own home.
Okay, so this intelligence thing intrigues me. Can you show me more?
Sure.
And then can we blow something up?
Later, Tim, later.
Okay.
So this is one of those big chillers I was talking about. Kind of like a giant refrigerator. What it does is it takes the water from all of the process tools, brings it in, and it chills it down to about 48 or 50 degrees, and then we can recirculate it again. But it takes a tremendous amount of power to cool all that water. This unit right here, just by itself, takes over 1 million watts to run. That's why it's so loud.
I have no idea what you just said.
So this is where we're harnessing Mother Nature. We're taking the cool air and we're using that to cool all of the water instead of those big compressors in the other room.
So how does it work?
It's pretty old school technology. We're just making it smarter here. We're taking the cold air, because we just predicted it's going to get colder, and we're blowing it over some pipes that have the hot water in it and dumping water over it at the same time. So what that does is just evaporatively takes the heat away and puts it in the atmosphere harmlessly. A lot less power. So this is where the process gets smarter, Tim, because everything in here is instrumented. We've got all that information here at our fingertips. But the magic comes when we can take the feed from Deep Thunder, we can start to make smarter decisions on whether we're gonna turn one of those very expensive chillers off a little bit earlier or delay turning one of them on. And that way we let Mother Nature do the heavy lifting for the chilling, and that's where the savings comes in.
Oh, I'm sorry, were you talking to me? Could you run through that again? All right, Doc, what do we got here?
Well, all that talk about cooling and heating got me thinking that we should use a little cool and a little heat to make a satisfying little boom.
All right, so what you're saying is this is kind of a model on how micro forecasting can help cities be smarter.
No, man, I'm just saying science is fun. Okay, don't try this at home.